Rational expressions. You are going to need your own sheet of paper for this lesson, so go ahead and get that out. Okay, first of all, I want to go ahead and define a few words for you, or remind you of a few words, I would say. Okay, the difference between an expression and an equation. Let's look at that. An expression versus equation. Okay, so an expression, the only thing you can do with this is to simplify this. An equation has an equal sign, and you can go ahead and solve for a variable. And that variable usually is an x. Okay, next word I want to look at is a rational number. So a rational number is just going to be a ratio of integers. And a ratio, remember, is a fraction. And an integer is going to be a positive or negative number. And then the last one is going to be a rational expression. And we've already talked about what an expression is, and we've already talked about what a rational number is. So I would say rational expression would be, let's see, how about simplifying? Let's see, simplifying integers that are in the form of a ratio. Okay, the next thing I want to point out is that if you are not doing well with simplifying or factoring, make sure you come in, because we are going to be factoring a lot in this lesson, and you've got to be able to do that really, really well and really fast. Okay, so your first problem is going to be x squared minus x minus 6 over x squared plus 2x. Remember, that is going to be a rational expression. I'm going to multiply that by x cubed plus x squared over x squared minus 2x minus 3. Now that's just your problem. The first thing that I would always do with these is simplify. I would never go ahead and multiply these out. So this first quadratic here, I would simplify, and that factors to an x minus 3 times an x plus 2. And that bottom one, I can take out a common factor of an x, leaving me with an x plus 2 times this top one right here. I can take out an x squared, leaving me with an x plus 1. And on the bottom, that's a quadratic, and I can factor that as well, leaving me with x minus 3 and x plus 1. And if that was difficult for y'all, you need to come in so that I can help you out. Okay, because this is multiplied, if you want to, you can go ahead and extend this line so that everything on top, and this is everything on bottom, and I can start canceling out. So this x plus 2 cancels, this x plus 1, this x plus 3 can cancel with this one. Now all I have is an x squared over an x, with just an x. Okay, let's try another one with subtraction this time. So this is x over x squared minus x minus 6 minus 1 over x plus 2 minus 2 over x minus 3. Okay, the first step that you need to do always is to see if you can factor anything. So this trinomial down here looks like it can factor to x plus 2 times x minus 3. Most of the time it's going to factor to the denominators that are there, but always double check, because it may not happen that way. Okay, so let's go ahead and rewrite this with common denominators. So the first one stays as is, so x over x plus 2 times x minus 3 I'm going to go ahead and move this minus up to make it a little bit easier. So this is minus 1 with my common denominator. Looks like I multiplied by an x minus 3. Moving this one up again. I'm going to multiply this last one by an x plus 2. Okay, do not try to skip this step right here. A lot of people try to do that, and then you're going to mess up, so make sure you do go ahead and write that step down. Now I'm going to combine everything, not multiplying the bottom because you might need that for later use, but I am going to simplify the top. So I've got an x minus x plus 3 minus 2x minus 4. And then let's see if we can simplify. Those x's cancel. So I got negative 2x minus 1. And I still have x plus 2 and an x minus 3. You could take out a negative on the top, but that's not going to help you simplify anything on the bottom. So I'm just going to leave that as is. How about a minus m over a minus a plus m over m, and let's do another fraction. How about a minus m over m plus a plus m over a. And by the way, I only use this because it's my initials, not because I like a and m. Okay, so what you could do is you could find a common denominator on the top, common denominator on the bottom, divide, simplify, blah, blah, blah. Or what I would do, or a more simplified way, is you could find the common denominator on the top and on the bottom. And it looks like your common denominator on the top would be am. The common denominator on the bottom is an. Okay, I'm going to multiply both the top and the bottom by that. So I'm going to rewrite this. This is a minus m, and this is a plus m over. I'm just rewriting it right now so that I can simplify. Okay. If I were to multiply am times this first one, this is like over 1. Your a's cancel out. I'm left with an m times a minus m. Minus am times this. Your m's cancel out, leaving you with an a times a plus m. Okay, all over. Same thing on the bottom. This is like over 1. Your m's cancel out, leaving you with an a and a minus m plus your a's cancel out, leaving you with an m and a plus m. Okay, so this is so much easier already. Let's come to my next step. I'm going to simplify. I'm going to distribute, so that gives me, let's see, am minus m squared minus a squared minus am. You should see that already these are canceling, which makes it easier. On the bottom, I have a squared minus am plus am plus m squared. And again, these are canceling. So I have a negative m squared minus a squared over a squared minus m squared. So the top and the bottom look very similar. How about if I factor out a negative 1 on the top? That leaves me with m squared plus a squared. On the bottom, oh, sorry about that. That should be plus. On the bottom, I have a squared plus m squared. So this is going to cancel with this. My final answer is a negative 1. You still get the same answer if you were to find common denominators on the top and the bottom. I just thought this was a little bit easier. Okay, last problem. X minus y over, now I'm going to make this kind of look nasty and make this a fraction right here. Okay, I thought that I could do the same thing on this problem, and you're eventually going to have to find a common denominator from this x and this over here, but I thought I would simplify this right side first, and I'm going to do that by doing a common denominator on this right side. And I thought that it would be xy. So I'm going to multiply the top by xy and the bottom by xy as well. So here's the x over y plus y over x. So the left side is staying as x. I multiply the top, that gives me xy squared. The bottom, the y's cancel out, that gives me x squared. And then that gives me y squared. So it made it a whole lot easier. So now this is really just x over 1. I need a common denominator. And it looks like it's just x squared plus y squared. So denominator here, x squared plus y squared. And this is x squared plus y squared. This top is going to stay. And I need to multiply this top over here by x squared, y squared. And again, do not skip this step. Go ahead and distribute. Gives me x cubed plus xy squared minus xy squared over your denominator. And this cancels. So this is x cubed over your denominator. That's it. You cannot cancel these x's because this bottom one is a binomial. It is connected as one. And that's it.